Get. All right.
Awesome. So I will be talking about accessing data on the cloud, a new PyHC package, and also open science, all in one giant mishmash, complete with a demo. But starting out, Cloud Catalog is a PyHC package that is both a specification and API. It's available from PyPy, so if you want to do the follow along at home edition, you can do pip install Cloud Catalog and then work with the demo that I'm going with. Cloud Catalog came about because it's really hard to do an LS on 1 million files that are stored in the cloud. Cloud data is just really big. And if you're trying to grab a lot of files, it's not necessarily easy to have a web interface or have to cut and paste or do similar types of things. So it was to make a very simple, lightweight standard that people can use to index data and make it available to others. And although it's for cloud data by design, it actually has open science hooks in that it's a way that you can publish data just through HTTPS and make it available to other people to fulfill your open data requirements. So I'm going to walk through a notebook. And if you go to the github.com/heliocloud-data cloud catalog link, which, whoops, it's a notebook. It doesn't have normal cut and paste, which I will paste into the chat. Then you can download the demo notebook and work it yourself. So, as mentioned, pip install Cloud Catalog will work with it. It's a PyPy package. It's a PyHC package, and it's primarily designed because there's over a petabyte of data stored in Amazon cloud storage for the Helio Cloud project, which includes all of C, the web, although we're still catching up on the past year or so, SDOs, AIA data at 1 minute cadence, all of MMS, contributed data set EUVML, and a few others that are potentially going to be coming out. It's a very happy-like standard. You give an ID, a start and a stop time, and you get a file list that you can then run through. And as mentioned, anyone can list data with it and make it available or searchable to others. So I'm going to talk about from a user point of view, and then I'm going to talk a little bit if you're a data owner and you want to publish data from it. And then we'll also talk if you're a dev for something like PySpeedas or similar, how you could also fetch it. Again, like Happy, it's a specification, and then there's also currently a Python API. Will there be other APIs? Who knows? It's decentralized. You don't have to register your data in any sort of database or other service. You control your data and your indexing. It's just a way to create a shareable and searchable index. And then behind the curtain, it's a JSON spec for the metadata, and then you put the indexes as flat files, CSV files. It's serverless and lightweight. Serverless was pretty key for the implementation because if you have a data set under a grant, you won't necessarily be able to maintain an active server 10, 20 years from now, but it's very easy to put flat file indexes that are accessible next to it. It's very lightweight, and again, it's currently for AWS S3. And one bonus is if you tell HDRL, hey, I put data up with Cloud Catalog at this location, it's now indexed and findable by anyone in the sort of Cloud Catalog Helio Cloud network. And future work, hopefully add hooks to PySpeedas and Happy, tools for users to be able to self-publish data more easily and be indexed, integrating with the VSO, and cross-linking with ESA Data Labs is also on our list. So I'm going to do an overview of how to get data in general and where we fit into the PyHC ecosystem by looking at a randomly picked April 17th, 2021 event. This is not a scientifically valid analysis. This is fetching data and plotting it with no scientific meaning, just to show the data fetching. And we're going to look at OmniWeb, MMS, SDO, AIA, fetched 5 different ways. And this show how, again, it's very familiar. So there's a PySpeedas example. You give a server, a data set, a start and a stop, subset of parameters if you want it, the PySpeedas call, PySpeedS has happy built in. So you do PySpeedS.happy with those parameters, and then you can quickly throw up a plot. You have your data for that event. If you go with the happy package, again, server, dataset, start, stop, optional parameters, do the call to happy and plot it. If you do this with Cloud Catalog, I had to make a CDF plotting routine because there wasn't a quick plot that I could find. But look, you have a data set, a start, stop. You make a call to the Cloud Catalog, and now you have a list that you can plot. In this case, rather than doing a loop for a plot, Cloud Catalog has its own built-in streaming thing because Cloud Catalog assumes you're going to want to rip through lots of files and do something with it. So it can use something called lambdas, but you can also just iterate through the way that you want. So there you can get your time series for it. Not the most interesting time series there, but there you have it, up and plotted. Um, so if you want, to know what's in Cloud Catalog, it has its own little search thing. So you can search for an ID and it will tell you whether it exists. And I put this snippet up to show this is the metadata that you can fetch via Cloud Catalog. I'll go deeper into the metadata for people that like metadata, but it's there. Now, if you don't do time series, but you do images like me, there's lots of ways to get images. I'm not going to show all of them, but if you're using SunPy and Fido, what do? Well, you give it a time range, an instrument ID, which is, instrument plus wavelength. You do a Fido fetch, and then you can go through and you can plot them. So exciting. Except I was having download issues. Cloud Catalog, same thing. You give it an ID, a start, and a stop. And then the only extra thing is you have to tell it where are you fetching that data from? Which cloud repo or top level domain has that information? And that's the decentralized part that says, oh yeah, this particular place has the data in this cloud bucket or this data source. And you do your call and then you can plot your data. Yay. So that's how it fits in. It's yet another data fetching mechanism, in this case, optimized for cloud stuff. So going back to the demo code and looking at the demo, again, the idea here was efficiency. It turns out it's both slow and expensive to list 1 million files or fetch 1 million files. But if you're trying to do machine learning, massive data sets, looking at every single upstream or downstream event in MMS, trying to do the total solar irradiance over 100 terabytes of SDO data for 1 year, you're probably going to be using a cloud system. So you're going to want to get the data. Very familiar looking demo here. You give a top level domain that has the data, and there are ways to find that through search. You give an ID, you can get all the JSON you want, etc. And you get your data. Actually, I'm going to switch to the one that actually populated so we don't have to do it. So in this case, doing this search for this time range, it found 1.4 million files. It's the cloud. You will not be downloading 1.4 million files. You will be ripping through them on the machine. And it turns out if you want to rip through that number of files, it will take you about 20 minutes to actually do analysis, which is pretty cool. How do you do it? Pip install Cloud Catalog, or I've become a convert of UV, so UV pip install Cloud Catalog, and then import Cloud Catalog. Again, happy like queries. You give a data set ID, you give a start and stop time, and you say, yeah, give me the pointer to the global catalog, and now give me a list of file keys. It returns it as a pandas data frame. So you can see, what does it have? Well, it has the start time, the stop time for that observation, the actual data key that you can fetch from. Files in cloud storage are called S3:/ instead of HTTPS://, and then the file size is provided there as a minimum checksum. Cloud Catalog allows for additional data fields, like the EVML set includes Carrington latitude and longitude and such. So it's extensible with additional metadata, but this is the bare minimum required. Start, stop, file key, file size. You can query the metadata on it. Oh, sorry, you can query the core data. It's, a pandas thing. Hey, what information do you have? Here's all the information. Start, stop, data key, file size. I'm not going to belabor that. And there you have your data. Now, going back to the overall architecture, it's a catalog of catalogs. So you own your own S3 bucket. An S3 bucket's an S3 disk that you can put in as big, cheap storage. For those that haven't used S3, it's basically like a tape drive. You can write, you can delete, and you can find stuff on it, but you can't append or do live database stuff on S3. And you can't actually rename files. And it's a object-based store that acts like a file system. So this is to really make it so you don't need to know how to do S3. But if you think of S3 as a tape drive, it's kind of an effective way to think of things. There's a global registry that anyone can basically tell HDRL, hey, please put my stuff into the HelioCloud Cloud Catalog network so it's findable. And you give the S3 bucket the top level, and that pretty much gives you what you need. So right now, the current cloud catalogs that exist are the HDRL data one. That's it. So there's only one endpoint currently, but other endpoints can and hopefully will appear. You can search the cloud catalog. You just do an invocation of, hey, just give me this object that's the entire catalog search, and it will find all the IDs, and now you can look for them. So here's a list of everything that was found looking for survey L2 ion, which is an MMS data set. And as expected, oh, there's 4 MMS data sets, 2 different instruments doing survey L2 ion. Now you know your data IDs for finding. Search is fairly broad. If you want to look at everything 94, because you're like, I want to look at 94 angstrom EUVML data, well, there's AIA's data and associated metadata, an EUVML contributed data set, a couple of those, and something that happens to have 94 in it, ST5-094. So this is your bona fide case insensitive search. If you're like, hey, I want to explore some of the cloud data sets that are out there. We obviously want to do better integration with See the Web and VSO, but having that basic search in there lets other people do tools on top of it. And you can also do multiple things. So here I did a search for keywords, and I'm just printing the IDs for anything that matches AIA, apples, or fly's eyes, all of which are strange words, but AIA, there's a lot of data. Fly's eyes turns out to be in the metadata for MMS1. I don't know what the detector term means, but it's something there, and nothing came up with apples. So it has some search capability. Working with the global catalog, that's in the demo. I'm not really going to cover it, but there's version and metadata stuff. The main issue, of course, is the local catalog. So say you have a data set you want to provide to the community, you stick it on an AWS S3, you put a catalog.json that includes the metadata for the data set as a whole to make it available to others, and then you have your CSV indices, and that's really pretty much it. The global catalog JSON has, ID, a title, and the index, which is where you've put the CSV for the individual files, and then a global catalog start and stop time. If you've worked with Happy, very similar. And again, you can do searches and fetches. You can get your metadata for it. This is all very Happy-like. When you go to request something, you get your nice little data frame. And say you have your list of 1 million files, you now can just rip through all 1 million files in cloud without having to do a download. If you don't have a cloud account, you can actually egress most of these things, but I'm not going to go into that because why would you want 1 million files to download to your computer? You would probably want to just go to VSO or see the web directly. This is for when you want to do bulk stuff, ML, long time baseline, multiple instruments, etc. To make that easier, it has built-in streaming methods where you can write a lambda or a function and say, please throw this function at this and then gather the results back. It's very cloud efficient. Here's a very simple example. I fetched a whole bunch of MMS data, and I'm just going to do a hash of the file. And it goes through, and it does that. So exciting. Or plot. You make a plot function. Here I'm plotting CDFs very poorly. And this one-liner will take the list of files that was returned and just plot them all for you. So again, large number of files that you need to process efficiently. That's the utility of Cloud Catalog. Then publishing your own data set, the full spec is available at both PyPy and the GitHub repo. It works for anything that's AWS or HTTPS. So this is the underlying metadata. You say, what version of Cloud Catalog are you using? You give it a name. There's enumerated words that you can do for egress, which is what policies are allowed, public or private. Private would be no egress, public is egress. And we're working on better handling of public user pays. For those that haven't used AWS Cloud, it's all about microtransactions. Every data access, every terabyte stored, every little bit of CPU incurs fractional pennies of charging. So if you run a cloud disk that people can egress or take data out of, if you're not NASA with their free ODR TOPS bucket that AWS gets for free, after the first 1 million reads or so, you'll start to get charged as the data owner. And it's fractional pennies, but if someone is mirroring your site or people are doing a lot of machine learning stuff that are doing accesses, every little ls or touch on a file counts as that fractional penny and it can add up. To provide safety, you can make your data public, but with user pays, which means instead of you having to pay for 100 users, all of whom are charging 25 cents a day worth of millions of files access to you, each user can handle their own 25-cent a day charge and make it safe for your data. So if anyone wants to talk sidebar sometime on, hey, how do I publish a big data set in the cloud but not be on the hook for the heavy costs? That's something we can talk about. Although the shortest answer is make sure the data has high community value and let Goddard HTRL and Brian's team archive it for you. So there's metadata defining it and then saying all the different test data that you have. And again, what does it do? Well, it's saying, hey, here is where the index is. And it points to a directory on the server. Now, you may notice this one is not S3. I actually put up some stuff on my private website and indexed it under HTTP, and it is publicly available through this cloud catalog, which was just kind of fun to do. What's in there? 4 D&D maps and an index. So I made an index file, local test underscore 2025.csv, because the format is data ID underscore year.csv. We presume time ordered for data. I'm working with the modeling people to go around with that. And we're doing one CSV file per year because that was a compromise between performance and ease of use. A 1-year CSV file, even for large data sets, is not prohibitively large and very performant, but it also means you don't have to regenerate older CSV files if you're adding the latest year's data, etc. And you can actually just download the CSV and operate it outside of Cloud Catalog. It's just a time-ordered file. What does your actual index look like? So exciting. A start time, a stop time, the data key, the pointer to the actual data, and the file size. Because Cloud Catalog is not slinging data, it's slinging pointers to data that you can then use with your program. So, the takeaways in narrative form, PyHC package, it gives you access to 1 petabyte cloud versions of CEDA-Web, SDO's AIA data, MMS, EUV-ML, and other curated data sets, which are growing constantly. We just added SuperMag data at 1-second resolution, for example, but we haven't quite come up with a tutorial on how people will use that. That will be coming out in the next couple weeks. It is very happy-like, or SunPy-like, or PySpeed-S-like. You give it an ID, start and stop, and it returns URIs to file. It allows self-publishing of data sets. And it has basic findability in there that you can do searches using the Cloud Catalog API to look at what data is available in Cloud Catalog. This also means that since you are publishing the JSON metadata in your indices, you can mint that as a DOI and put that in your publications or in Zenodo, and it's now something that is findable. Key to remember is the JSON metadata from the Cloud Catalog spec and the CSV indices do not require you use the Python API because the CSV files are simply start, stop, pointer to file, file size. People could actually download them directly, the indices directly, if they don't want to use the API or if they're using another language, etc. We would like to work hooks for Cloud Catalog into other packages, the way that PySpeedas incorporates Happy, for example, and that SunPy incorporates Fido, so that you don't need the Cloud Catalog. You can just start searching IDs, but we don't have a time scale for that. We are making tools for data creators to find stuff. And if you really want an exercise, import Cloud Catalog, point it to the HDRL Helio Cloud data archive, and look for a cool See the Web data set or SDOAIA or similar. So that is the overall briefing on Cloud Catalog. I'm going to stop screen share. And what I would like to know from people is, hey, do you want to talk about me writing stuff for PySpeedas, SunPy, etc., so it can call Cloud Catalog? Or do people have open science use cases or questions there? Or are people wanting to look at cloud data and want some tutorials or examples? Because we do have tutorials for how to rip through a year's worth of SDO data or a year's worth of MMS data, just to do the kind of long-term studies that you can do when you have 1 million files. So question time. Hey, Brent, by the way, they had me go first just to get things rolling. So you are the closer for this particular session.
Yeah, I lost track of time. Sorry about that.
I was just figuring it was the traditional APL, 5 minutes late because you're running from one thing. So, but yeah, so any questions or thoughts or people that are package developers like, hey, we should talk offline, or hey, I want to talk more about how to analyze 1 million files in the cloud, because this is really just boring enabling technology, but I consider boring technology that's necessary, fun puzzles to work with.
Not a question, but just a comment because it has to be said that this is great work and it's kind of a key part into our science platforms coordination working group stuff that I'll be talking about later. It's important to get access to huge amounts of science data in the cloud, and this is helping us do it.
Yeah, one of the cloud paradigms we're trying to convince people is don't download data locally. Spend the $1.50 to do your calculation on 1 million files in 20 minutes on the cloud. It will save you time overall. But in the broader cloud sense, we have lots of tutorials on how to do that in AWS cloud. And HDRL is pretty much giving free accounts to anyone doing legit research on that kind of thing. As we get to this whole idea of data, floods and data lakes and too much data to handle, having multiple workflows is a good thing.
Definitely.
Maybe I
Any-
can ask, sorry,
Oh, go ahead, go.
do you have a sense of how much data total is kind of like available by Cloud Catalog right now, like a number of terabytes or petabytes or something?
I think we're at 1.2 petabytes and starting to fill up the 1.5 that Helio Cloud has. We have all of See the Web through middle of 2024. We have all of SDO AIA at 1 minute resolution. And now we have all of SuperMag at 1 second resolution, which is just a teeny 20 terabyte data set.
Awesome.
And we're
And
waiting for like new research that is like, wait, now that I can finally look at stuff, I don't have to look at one event. I can look at 1,000 events kind of stuff.
And how did you prioritize which data sets you got in there first? Was there a process for that?
That's a Brian Thomas and HDRL prioritizing question, but it really was the classic, what are people using? Especially on long time baseline. MMS was the first pilot set because the MMS researchers, there's so much data from 4 spacecraft, and all of their research is, hey, we need to see stuff over 5 years. So they were very limited by being able to do stuff on laptop. But adding an SDO AIA was to get an imaging component in and obviously see the web for space physics being available. That was partially because um, Bobby Candy's group was like, hey, we will help facilitate the transfer. So there is a certain when you have a good working partner on it. ESA Data Labs has their own storage, and we're trying to find ways to mirror data across them and make both of them available. So there may be some caching of ESA Data Labs. The primary driver is saying, I, as a scientist, am doing research on X. I need access to this because I want to do long time baseline or machine learning or similar. Can you put that data in there? Because the HDRL one is not an archive, it's a data cache. There's no guarantee that the data will still be there for any given instrument 10 years from now. You know, VSO, see the web, they have that. Oh yeah, 40 years from now, the data will still be there. Cloud data, because of the size and storage, it will not be kept if it's no longer relevant or being used by scientists. It's not an archive. It is a data that people are actively using because of the microtransaction component.
Maybe that answers the question I'd wondered about, but I mean, you said you're nearing the, what was it, 1.5 or something petabyte limit of available, data to work with on the cloud. What happens when you hit it? Do you just start decommissioning older data that maybe people aren't using as much? Or I'm curious.
Above my pay grade. But yeah, like we have all of See the Web, but there's a question about how much of See the Web is archival um, or even necessary. Like, do you need cloud access to Voyager data? Probably not, because that is small. So if we had to start prioritizing, we'd look at, use patterns, etc. There's also the possibility that they could get more free space from Amazon because Amazon's providing it free. But most data sets that are user contributed tend to be in the tens of terabytes, and it does, there's still a third of a petabyte unclaimed. So there's definitely room for like people making machine learning ready subsets of data that exist already. Because a lot of times if you're doing machine learning, you can't take a normal set of solar images where the size slightly changes due to the spacecraft position and there might be rotation things because machine learning stuff will say, I've noticed a solar trend that happens to occur on a 6-month cycle. And you're like, that's the orbit of the Earth. No, that's not a real thing. So if people make contributed data sets, it could be a good place to look at archiving. And Jack over at VSO has said that he would actually like to mirror contributed data sets that people provide to HelioCloud into VSO as the perma archive, if it falls under VSO's province, like image and such. And I'm sure See the Web would like to do the same for significant ones. So if you are making machine learning or large data sets, talk to me or talk to Brian, and we'll connect you up with the Goddard people.
Any other questions for Sandy? All right.
Thank you.
None left over. Does this conclude your presentation for today, Sandy?
Yes, it does.
Alrighty. Well then, Brent, we're running now a little ahead of schedule. So would you like to go ahead and present?
Sure.
Awesome. You
yeah.
have more time.
Sweet. Mine will be short, so just FYI. Can everybody see my screen?
Yes.
Okay. Yeah, I'm not doing video just due to the connection I have right now. So hope that's all right.
Yeah, that's
Okay. Yeah. So I'm going to be talking about S3 awareness, specifically for the PySpeedS package, but it's also for other packages within PyHC. And this is actually a funded effort from a NASA ROSES HTM grant that has finished. And we just wanted to report on what we did regarding PySpeedS. And I was a co-I when Lee was the PI and Vicky was also a co-I. I should be able to advance my slides, but there we go. So the summary of what we did and the goal of what we did was just to increase access to cloud storage of big data more efficiently. And so the aim was there are several PyHC packages that are not cloud aware, and meaning that they cannot work with the AWS cloud or other cloud storage providers. And so we wanted to increase that just to be able to have them connect to the cloud and also just be able to look at data that's on the cloud. Our approach, so what we did was we wanted minimal API changes. So very behind the scenes operations, mainly focusing on changing file operations, so like reading and writing, and then data retrievals as well. And that this will be a big part of with PySpeedS and the workflow that's typical there. Our implementation used the FS spec package. This is a file system spec package. It simulates a file system, but underlying it's actually using cloud storage. And I'll get a little bit more into that. We also did do unit testing using the Moto package, which is specific to AWS unit testing and cloud structures there, cloud architecture there. So the usage we did with PySpeedS, if you want to use it, so you will need some setup prior to just installing PySpeedS. You also need the AWS CLI. And there's actually a link on the README of PySpeedS to the documentation of how to set this up. But you need it currently to be able to actually access cloud storage. So to read or write data from cloud storage, which in AWS that's S3 buckets. You can also use like your own AWS storage to write to it, but be careful with this because similar to reading data, if there's public data out there that you're trying to access, you could very easily try to write to that same place. And we, due to permissions, it will probably error depending upon how that S3 bucket permissions are written. So you want to just be careful with that. Streaming data from the cloud is the preferred method. Why? So with PySpeedS, the typical workflow is to go retrieve files from a server, place them locally, and then read them from there. Here, you wouldn't have to download files. You just stream the data. And then we also made it possible that if you do still want to download the data, it is still there. But we do not recommend that, even though that functionality is still there. The storage that we implemented was AWS cloud storage, which could be public or private using this FS spec package, sorry. And typically right now we are using Helio Cloud as Sandy presented with the cloud catalog, but we're using the S3 buckets directly. And why? Because it contains a lot of data. And so the S3 path that we use is there. But there's a little bit more as far as this S3 path and how you use this within PySpeedS. Let me just double check to make sure no questions. Okay. Feel free to ask questions or interrupt if you have any. So an example is just we decided to implement either a configuration change. So on the documentation, it says the SpeedS data directory, which would actually overwrite the configuration in PySpeedS of the local data directory. But also, instead of having a remote server, let's say last holdings or something like that, you can actually change the remote data directory to an S3 path as well. However, these paths need to be mission specific. So every single mission data that you're going to pull data from or stream data from, you have to actually set that path specifically per mission. And that's also the case in the configuration of PySpeedS. There are several modes for cloud interactions. So primarily streaming data again from a remote S3 bucket. You can use what's we would think of as a local S3 bucket, aka your own personal S3 bucket, or some bucket that you don't want to, you have permissions to write to or something like that. And then another one is you could download from the remote server to your local bucket as well, or then download from S3 as a remote server to local storage, aka your file system or your local laptop. And so on the right is just a snapshot of a Jupyter notebook of this. So typical PySpeedS with the tplot import. Here is the actual S3 for ACE, given the Helio Cloud storage there. And then here's that configuration. Notice the ACE specific there. And so we set that remote path to an S3 bucket holdings there. And then we can just get the instrument data here. And the data type H1 is actually specific to this as well. And then we plot it. And so specifically, I did 2012 in March. This is a big CME that was observed by ACE. And you can see that in the change here of the magnetic field. So looking forward, so as I said, this is specific to PySpeedS. We also implemented it for SunPy and AstroPy, but also FSpec. The reason why we implemented and used that was because it's also used in Pandas, and it actually provides functionality for other protocols. So like using Google Cloud or FTP or other URI specific protocols. And so this adds more flexibility to our implementation if those things change. Some work to be done and some caveats. So the data retrieved, so like with what I showed on the previous slide with ACE, there's some different path structures. So between PySpeedS's configuration and Helio Cloud's S3 holdings. So if, for example, like stereo, PySpeedS would go to this remote holding. So this is the default URL, but then within the load.py of stereo's PySpeedS package, it actually adds these folders or path placements in there to try to find the data files. Whereas in AWS, the Helio Cloud one, here's up to stereo, but then we have a different path here. And so you have to be careful where the data is and how PySpeedS is looking for it. And so that could be pretty tricky given, you know, some mismatching as far as like different data holdings, even of years or even like the data types that were there. Like with ACE, the H1 that I mentioned, I believe the default in PySpeedS was like H3. And so I had to change that in PySpeedS so that it would fit the holdings that's in Helio Cloud. We can also use fspec anonymously, and this would mean that you don't necessarily have to have an AWS account, but you still need the AWS CLI. I know that sounds very contradictory, but you can configure the AWS CLI without an account. You just need the region and the file types. I think that would needed for that configuration. And then it would be able to pull and see this S3 holding since they are public from Helio Cloud. However, in PySpeedS, what we did was we turned this off. So as far as the anonymous, we do not allow anonymous users to connect or use PySpeedS anonymously because that could be a lot of usage, and that's actually the next point here. AWS usage can become costly if not used correctly. So file operations within the same region isn't cheap. There are charges for reading data and things like that if you're not in the same AWS region, and then also downloading files through PySpeedS, which is kind of the default workflow, isn't necessarily a cheap operation for cloud storage. Streaming data, again, is the preferred method. And I think that's all I have. Yep. Any questions?
Yeah.
None for me, but great job, Brent.
Thank
You were just on the last point there, so I'll start with how you're paying for things here. Um, so you're linking it up to your own AWS account, right? When you're doing this, so I'm guessing that just any charges that you
I'm
incur when
sorry,
you're downloading.
are you asking something, Sean? I didn't hear anything.
Oh, um,
I heard you, Sean.
okay. Glad to
Okay.
know.
Can you hear me?
Yeah, I'm hearing you, Sandy.
It may be me with my connection. Can you try saying the question again?
Yeah, I was asking how you get charged for things when you're doing this. Like, did you mention that you have to link up your AWS account before you download things? So does that mean that any
Yeah, so
you
typically it's not a charge for you per se. It depends on how the data is storage is set up. And Sandy can correct me if I'm wrong as far as how the S3 buckets for Helio Cloud are set up of if there's a throttle or if there's a usage limit on it, but typically the provider or the owner of the S3 bucket would pay for those charges. However, you can change it to where it's the user that's accessing that to pay those charges of access rather than the provider.
Okay, so it's kind of on a per data set basis, just what the rules are set up for it.
Yeah, it really depends on how the bucket is set up and also how you access it, because also different operations cost differently, and that's an AWS thing.
Totally, that makes sense. And I'm guessing the turning on anonymous is only going to work for the data sets where the provider pays the costs. Yeah, like I'm guessing there'd be some kind of error if you try to anonymously access a paywall data set.
No, so that's only if it's public data. If it's not public data, you will have to have a key or some kind of authentication to access the data on those S3 buckets.
Nice. Thank you.
Yep.
Hey,
I
Brent,
have a question
Jim Lewis
for you,
here.
Brent.
Oh.
So the FS spec that you've implemented for PySpeedS, how easy would that be for other PyHC packages to use as like a template for them making their stuff also cloud aware?
It really depends on how they are tied to file operations. So the majority of PySpeedS, we modified the PySpeedS /utilities/download.py, and that actually did the majority of the functionality. There were mission specific ones that we had to track down, and that can get really hectic, especially if there's custom file operations or download routines. And so it really depends on what the code looks like and how it's actually reading and writing from a file system.
Okay, thanks.
Go ahead, Jim.
Hey, Brent, Jim Lewis here. Just want to say thank you very much for contributing this. This is going to be super useful. I'm wondering, you know, did you encounter any difficulties with sort of the PySpeedS architecture that, if you had your way, maybe you would, was there anything you would change about how our sort of download support works?
Yeah, so I think we've actually talked about this, you and me, of the way you download files and streaming data. If you had implemented where you use a file handler or a file open file object to do that, that would probably be more preferable, and I believe that's what SunPy does. Rather than in PySpeedS, you actually get the file list name and work from a string rather than like an open file handler. And so that would ultimately be a lot of work for PySpeedS to re-architecture basically how you use that and how you interface with like download.py. But that would probably be the preferred method.
Yeah, and then I guess doing it that way, I guess one of the sticking points might be that I think we would need support in CDF-lib and the net CDF package and other file readers to support passing an open file handle rather than something that's assumed to be a file name.
So I'm going to chime in. CDF-lib actually does it the way that Brent suggests now, where it treats things as an object. So you can pass file
It actually
handles,
doesn't.
byte
It's
streams,
still,
or S3 URL.
so CDF-lib actually uses the Boto package. This is different than fspec. There's actually, oh, I don't know if y'all can hear me or not.
We can.
Okay, yeah, so the CDF-lib, there's actually, if I'm not mistaken, a proposal in that I'm a co-I on with Brian Harder with last about trying to implement fspec to CDF-lib, but currently it's using the Boto package, which there are some differences in that implementation. But it does work, as Sandy says. So it can read CDF files on the cloud right now.
The fact that CDF-lib doesn't use fspec caused the SunPy implementation of fspec and S3 URLs some trouble, for what it's worth. There's now like you can pass in an fspec file and then give it over to CDF-lib, and you have to convert it back to a URL for it to be opened again. And like it's a bit weird, but so it would be good to see that fixed.
Yeah.
All right. Any final questions for Brent? Going once, twice, and done. All right. Thanks again, Brent, and also earlier, Sandy, for your presentations.
Yeah. Thank you, and sorry again for being late.
No worries, no worries. All right. Well, let's go ahead and move on to the final topic of today, just a few minutes early. Sean, the rest of the time is yours.
Ooh. Sounds good to me. Let's see here. I was getting this ready just a second ago. I'll just make sure that I share the right desktop. And toward the very end of this, I actually do have a few video clips. So let me make sure that I hit share sound. And ideally, that's all I have to do for that to work. Cool. So we're looking at update from PyHC tech lead. Yeah,
Yeah.
sweet. Well, then I guess I'll just take it from here. So this talk is gonna have kind of four main parts, split up kind of into two halves. The first part here is going to be I'm giving an update on the Science Platforms Coordination Idea Working Group that a few of us are a part of. I presented that for basically the first serious time at the fall meeting, so this is kind of like the first update from since we've been doing things. Then I just wanted to give a quick shout out to some of the side projects that I've been working on, namely the PyHC repo templates and the documentation hub. Although I have presented both of those at telecons already, so when I get to that point, I'll be asking people who's seen it, and depending on the audience, I might not go super in depth into those. Then I have this very visual slide of my near-term vision for PyHC's future, and I want to talk about how what I've been working on lately fits directly into making that vision a reality. And a good part of that discussion, which is the fun part for me that I'm looking forward to getting to is talking about AI stuff pretty much. One of the bad pieces of news from trying to implement the vision is that I was not able to get funding for PyHC chat over the last, 6 months or however long I was trying to do that. But there's a bunch of off-the-shelf tools now that essentially do everything that PyHC chat was supposed to do. So we'll be talking about that a little bit too. And without further ado, that's what I'll be spending this hour doing. I think I'll just jump right into the science platform stuff. So I'll go on this for about 15 minutes and then give a break for people to ask any questions, have any kind of discussion on what I talk about, and then we'll go on from there. So just to remind people who may or may not remember what this is an international working group. We're trying to develop international standard software computing environments for heliophysics. Here's a quick look at our members. I'm one of the co-chairs with Jan Reering from ESA, and a couple of the people in this members list are on this call here, so you'll recognize some of their names. Essentially, this came from the 2023 Idea Cloud workshop, where just a lot of the discussion at that meeting at the time was people saying they wanted shared heliophysics environments for doing work in the cloud because, things are moving to the cloud. And by the end of that meeting, some people had decided that this sounds like a new working group. And by December of that year, we had started meeting together monthly. And we still meet together monthly. That's our meeting cadence. Um, by February of the next year in 24, we created a survey to basically just ask people in the field questions about their environment. I think a lot of you have actually taken this. I recognized a lot of PyHC member names, so I appreciated the data we got from that. If you're hearing about this for the first time and you feel like being a nice person and giving us some data about your environment, we're still looking for more. This QR code will appear a couple more times before I'm done talking about it. But it's basically just a Google form where we're asking you to pull up a Python environment for a project that you're actually working on at work and just tell us some facts about it. So we were running that survey as like one of the first things we did just to try to figure out what kinds of software people would want to put in a shared environment, but then to not let that slow us down in testing the tech stack. we went ahead and used the HelioCloud base image to just prototype what it looks like deploying these things with the different partners that we have. And that sort of brings us to this year, where since the start of this year, we have been deploying various flavors of these environments in both Binder and ESA data labs. We've been categorizing and sifting through our survey responses. And just to stop there for a quick second and to say a couple things about our deployment partners. We are working with 2i2c and ESA data labs. They're the main people who are going to be hosting these platforms for us, where 2i2c.org is their website if you want to learn more, and datalabs.esa.int. I will have these at the very last slide in this portion of the talk if you want them again. And basically we get three main kinds of things from them, which is 2i2c offers a binder hub where they have a grant from NASA for NASA just to pay all of the binder costs. So that's nice that it's, actually sustainably funded. And in fact, the PyHC environment being spun up with this was one of the biggest use cases that they had so far. And 2i2c used that to like turn back to NASA and say, hey, look at this great stuff we're supporting. You should keep funding our binder hub. So that's a good bit of news. They also have a authenticated Jupyter hub. Whoop, I triggered my celebration animation. That's awesome. Their Jupyter Hub is authenticated because it offers a lot more compute resources than just the free Binder Hub, up to many, many gigabytes of RAM and dozens of CPUs. So there is an option to get compute that is more powerful than your laptop. And then ESA Data Labs is just a Jupyter Lab platform, so not too dissimilar from any of this stuff, but their big thing is that they've connected all of ESA's petabytes of data into this cloud environment. So when you're working in a notebook in ESA Data Labs, Jupyter Lab environment, there's like folders that just have petabytes of ESA data right there to work with, which is super awesome. This is what the HelioCloud base image looks like in Binder. If you've ever used Binder before, this is immediately familiar to you. It looks the exact same in Data Labs, except it has this lovely European Space Agency banner. And then over here are the data by workspace and team workspaces folders for all the data we were talking about. And this is a new bit from the fall meeting, is that the PyHC environment has now been deployed into I2C's Binder environment. So if you have not actually played with the PyHC environment lately or ever, this is what it looks like now. When you open it up, you get this lovely welcome page that I made for us, which just kind of explains what the environment even is, what is it for. We give some links to the documentation hub and talk about these, import and unit test notebooks that come prepackaged in there. So that's all good stuff. And that brings us to now, where we are just kind of building and iterating on this. My next task is going to be to build a couple environments based off of the survey responses that we have, because we feel like we're at a critical point where we got enough data for it, just about. And yeah, that segues nicely actually into talking about what kinds of stuff we learned from this survey that we've been running. So I actually showed this slide at the fall meeting, and there's that QR code in the top corner if you want to care about it. Basically, our response, we kind of broke down our responses into four main categories of work, which are shown here. And what we've been doing since then, this is the new bit this year, is we've been looking at the basically the pip freeze files that we got from people, and we've been categorizing them into one of the four different buckets that we identified, and now we have the top packages for those kinds of categories. There are hundreds, as you can see, there's like 885 packages in our largest of the four categories. And these slides are, I'm not expecting you to actually read the text because I'm sure the text is tiny and this is an overwhelming amount of information, but it's a little bit overwhelming for us too. So we're sifting through it. One of the things that we're doing right here and this is just to be transparent and to talk about what's currently being discussed at the working group, because this is just where we're at, is we're trying to filter out some of those packages to decide what we want to keep. And we figured it'd be a good thing to have some kind of cutoff somewhere in the responses to where, like, maybe if more than half of the people in a given category agree that they use this particular package to do that kind of work, then maybe there's some validity to it. And, that removes some of just the one-off packages that maybe just one individual had, and we shouldn't necessarily include it in our environment just because one person had it. There's also this other little relaxed cutoff to where if only a quarter of the respondents used it, we could consider including them. But we like the split up of over half the respondents have to have been using it, partly because when we do that, we get this intersection of 85 packages that every survey respondent agreed they're using. So we figure we can at least start there. But I won't drone on about that anymore. It's going to be our jobs to get creative and do some data analysis and think about packages and use cases and put good stuff in there. And that basically brings us to, the future work where, we'll be finalizing all of those. Once I make at least a couple different survey-based environments, we're probably not going to make all 4 because it seems like that would be overkill and there's enough overlap in the packages for they wouldn't even be unique anyway. So probably like 1 or 2 environments based on the survey results. We're going to be making these environments and the packages within them citable for reproducibility and for just attributing the work and everything. Those are going to be using things like DOIs and complex citation objects, which Rebecca Ringett could talk about more, but I do not believe she's on this call, so we're not going to hear about complex citation objects today. And then basically, we're just going to want to start getting users and do usability testing and put it in hands, get feedback, and go from there. I had this one last slide that kind of summarizes things and shows the future vision a little bit. So just to summarize there, we kind of have like these different groups, these different kinds of environments we're making, where the first one that we started with was the HelioCloud base image. Think of that as like the emptiest, most basic image we could have, where you would use that almost kind of like Google Colab, where you are expected to have like pip install statements or whatever at the tops of your notebooks to pull in whatever packages you need, because you're not going to assume that environment starts with anything pre-installed. The PyHC environment is kind of the complete opposite end of that spectrum, where we're just it's the kitchen sink approach, where everything is in there at once. It already has all the heliophysics Python packages installed. It's a huge environment, like I think 16 gigabytes. So that size is not ideal. So you're not always going to want the environment that has everything pre-installed. We did do a demo of starting with the HelioCloud base image and then slapping all the PyHC packages on top of it. That was an interesting thing. So HelioCloud plus PyHC does exist. But then somewhere in between not having really anything installed at the beginning and then having everything, these survey-based environments should ideally have a reasonable set of packages specifically for the use cases we're identifying. And then, if you actually want to do serious work with this, you're going to want to use the authenticated Jupyter Hub, which is what this video shows. You're basically going to log in to the thing first, and you can be presented with this drop down of options where you can imagine, instead of what's being shown here, the drop down options are these different environment types. And you can't really see the resource options because they scroll by too quickly there, but they do go up. I have here in my notes. Their largest resource option has 121 gigabytes of RAM and 16 CPUs. So that will certainly be more powerful than any laptop you will ever own. And with all the work being done by Cloud Catalog / if you're in the ESA Data Labs version of this, you're sitting next to all these petabytes of data. So it's like really the best of both worlds, where you get to use a more powerful machine with closer, cheaper access to the data that you want to use. And, because this is all done in the cloud and we've done a lot of thinking about pre-installing software in there. Hopefully this is the easiest and simplest way to get up to work with doing heliophysics, science, and the cloud brings a bunch of good stuff. Not much more I can say about that. So I'll just point out one more time, if you have not taken the survey to tell us about one of your environments, we would love for you to scan this QR code and do that. This one below it is the PyHC environment and binder. I would encourage users to play with that if you haven't seen that. And here's the websites to our two partners. And then I'll just pause here for a second to ask if anyone has any thoughts or questions about that. Happy to blow through and keep talking about it, but
So I do have a question. You said PyHC has funding to provide capabilities and such to people. No, I'm sorry, 2I2C. 2I2C has funding to provide accounts for people?
They have a grant from NASA that pays for the usage in their binder hub. And yes, I also assume that that does fund the Jupyter Hub resources that are behind their authenticated paywall there. All you really need is to request access. And so far, I'm told I'm the only PyHC member who has requested access to the big binder and the larger resources. But if anyone is interested in trying them, I can certainly get you the 2I2C email where you request it.
Is this like a cryo cloud pilot where they have several years of funding to hopefully be stable?
I don't remember. I do know CryoCloud was like the work that happened before this was inspired. They worked very closely with them, but nah, I couldn't tell you for how many years it was going.
All right, thanks.
Anyone else? I'll give it like 10 more seconds of uncomfortable silence in case someone wants to get brave. Okay, not hearing anything. So I will move on to the side projects portion of this talk. And here, really, I'm just, like I said, going to be showing off the PyHC repo templates and the documentation hub. So it would actually be a benefit here really quickly. Before I talk about the PyHC repo templates, if people who are at their keyboards and listening to me right now, can you use the raise your hand feature on Zoom to tell me whether or not you've already seen this repo template in the telecom presentation or not? Seeing a couple. But hey, that is not everybody raising their hands at once. So that tells me that I can spend at least just a little bit of time actually going through this because this will be new for some people. Good to know. Thank you. This is what it looks like here. This is the first repo template that I've made. I'm planning on making a few different variations of this, but essentially it is a GitHub template. It is an official template, I should say. It is not just a repo that has a bunch of files in there, but for those who didn't know this, GitHub has an actual templating feature. So there's this green use this template button in the upper right corner. So people can make repos that are built off of it. Seems pretty obvious, hopefully, what the idea is here is just to give new package creators a starting point to make, a Python package that follows PyHC standards out of the box. It also just demonstrates what, a simple hello world package that follows PyHC standards looks like. And in the future, I'm imagining building, like I said, a few different versions of this that could do a few different things. Like we could elucidate the differences between the FEP4 tiers, like the bronze, silver, and gold by just having different templates that meet the various standards. Or I also really want to make a couple that show how to wrap different languages in Python. So like C or Fortran code or something. Right now, there's a Hello World Python script inside this template. I'll just open up main. Yep. It's got nice doc string. It lints to 100% correctness. It prints hello world. And we even have a test that tests that. And if you run PyTest with code coverage, we get 100% coverage, which is awesome. But you could imagine this being hello world written in like C or Fortran or something. And then we could show how you're supposed to wrap that up in Python nicely and package it. And even in this template here, I'm kind of talking out of order now, but I have a GitHub workflow that automatically publishes the package to PyPI each time you make a release. And I can imagine doing the same thing to show how you handle the complexities of publishing a package with different languages built in. So eventually there should just be a few different versions of this kind of template to show off how to do the kinds of common things we would do. Pausing for a second. Just what is in here? It's basically, I just worked backwards from the PyHC standards, looking at everything that we require to be in a package, and I just stuck them all in here. So we have a folder for docs, which is just empty right now. My PyHC package inside a source folder, because as we heard from Nick yesterday, that's become the common way to do this, is to put it inside source. There's a benefit. We could talk about why. You got unit tests that already have 100% coverage, like I mentioned, an empty change log, this citation.cff file, which is just a nice thing to have. You can modify, and it works with this repository feature, so you can make citing your work easier. Code of conduct, contributing. I got an open source license and the start of a PyProject.toml. And of course, the README tells you everything you need to know about using this. Everything from actually clicking the use the template button in the top corner to like decisions we made on code style. Basically following PEP 8 is the big thing with our standards. I have some stuff about how to publish a package to both PyPI and Conda, because we like to encourage both. This is already set up here to mint a DOI for every release, in addition to publishing the PyPI with every release. And this little 5-step thing here tells you how to do that. And if you want a more detailed step-by-step, there's this guide you can use. I explain those citation files. I am also pointing to the PyHC documentation hub and pointing out to people that at the moment, if you start with read the docs, you get automatic inclusion in PyHC documentation hub. You're not required to use read the docs, so I give alternatives here, and I'm hoping to actually integrate all three of these into the search capabilities of the documentation hub, but that's future work. Blah, blah, blah. Couple notes on how to play nicely with the PyHC environment, and then a link to our standards and how to submit a PyHC package in case anyone makes an awesome package with this template. And there's not really much more to say about that. It's just a repo template, but I'm already seeing a thing in the chat, and it's just a link to the template. Thank you, Nick, for putting that there. So that was pretty much what I had to show off there. Any thoughts before I move on to the documentation hub?
In your documentation section, you should be clearer that you can use read the docs to host things built with Sphinx, MKDocs, or JupyterBook.
Oh, I hadn't thought about that. So you can actually use one of these different builders to build your docs, but you can still host them on a read the docs website.
You can build your documentation with anything you like on read the docs with enough work.
Sweet. Well, then give me a second to write that in my notes here. I appreciate the note. Thanks, Stuart. Anyone else? Or if not, I will move on to the PyHC documentation hub. And I think again, ooh, I heard something.
Oh, that was me. I was saying forge ahead.
Forge ahead. Yep. Maybe I'll do the same question. Use the raise your hand feature, please, if you were at the telecon where I talked about the PyHC documentation hub. Cool. So similar situation. So I will actually spend the time to actually just explain from the top to bottom what this one is. I'm proud of this one actually. This came together pretty quickly and happened really recently. I was demoing this for the first time at the fall meeting, but it was just a prototype that had only the core package documentation back then, and I had built it by making copies of their documentation websites. And I was not proud of that. That was never going to be a sustainable way to do this. So I'm proud to say now that the new version of the PyHC documentation hub links together the documentation from not just core packages, but all other packages that use read the docs. It is a one-stop shop for all PyHC package documentation, not just the ones that use read the docs. There's a unified search for the read the docs using ones, and this was a core part of my vision for PyHC, which I'll be showing next after this. And I have this open in a tab here, so I'll just show you what this looks like. Just a single page. It'll look familiar to you because it looks like a read the docs site. All the available packages, these are all the ones that use read the docs for the documentation, and you can click on any of them here to open the actual documentation page. There's just this one section for the few PyHC packages that don't use read the docs yet. So they're not included in the search, but if you want to, read about any of them, like Cloud Catalog, for example, you can just click that and it still links to the documentation that they do have. And then the killer app here is this unified search. So this search will go through all the packages. So, I guess I already had this plotting a difference image from SunPy up as the most recent one. So if I knew I wanted to do that, but I didn't know that SunPy was the package or how to do this, you could just go and search difference image. And what do you know? It's the first result. When you click these, it opens up in a new tab and just links out to their documentation. And I'll note that the results are organized nicely by PyHC package along the top here. That's something you would never get with a normal read the doc search because that's just not a feature in read the doc search. And that's only possible because this is not actually the read the doc search modal. I painstakingly rebuilt this thing from scratch, including doing all the CSS to make it look exactly the same, and little things like when you start searching for words, the magnifying glass turns into a spinner for a second, and the results load. So this works exactly like the read the doc search, but I built it from scratch. That's the thing I'm going to pat myself on the back for. But this just lets you find capabilities and find documentation for things in the most unified way that PyHC has, at least. So that's the basic idea. I could drone on about it, but there you go. I'll leave this up for a second. Any thoughts or comments before I move on? I've been making actually good time here, so I'm going quicker than I expected to. Mhm. Well,
Yeah, I'm just curious. How are new packages added to the PyHC documentation hub? Is it just sort of like curated by you, or
yep, it's just curated by me right now. It's
okay?
become a new thing that I do anytime a new PyHC package pull request comes through the website. And I
All right.
basically just have a config file in the repo that is just a list of all of the packages that can be included in the search. And then I just copy, this is just their package name with a link to their documentation site, and then I pull the description that they submit in their YAML file for the PyHC submission.
Oh, okay. I see. Cool.
Yep. And so that's one more thing that people get from adding their packages to PyHC is you get immediately added into this great search tool, and people will discover your packages, maybe even by accident. So good stuff.
Nice.
All right. Well, if there's nothing on that, we're kind of right at the halfway point. So I'm actually doing kind of perfect on time. That's pretty cool. Um, this is going to be the part where I showed this slide for the first time at the fall meeting, at the last meeting we had, which was kind of, I had finally made, I thought, a nice visual representing, my near future vision for PyHC, like what I'm building towards in doing all of these things. And in my mind, if we can get to a place to where all of this exists, PyHC will be a well-oiled machine that is churning away, achieving all of the goals that I think we were originally tasked to do back in 2018 when we were created. I mean, not going to say that the whole field is solved by the time I get these 9 points done, but I think that really gets us a lot of the way there. And just walk through them quickly. That was, I wanted the PyHC environment to exist so that there's one place people can just go to a zero setup hassle to use all the PyHC packages and just to prove that they can all work together in an environment. That wasn't deployed at the fall meeting, and that now is. The gallery has been a long forgotten thing in PyHC, and the current state of the gallery is very sad. But we have a vision that I'll talk about in a minute for what it should be and how it should be built, where the main insight is that we should be automatically scraping examples directly from existing package repos and documentation, etc., so that no one has to manually submit gallery examples and then update them every single time their code base changes, because that would just be way too much work to maintain and no one would ever do it. But having a gallery will be important for us, I think, so it's still part of the vision. We want every PyHC package to be installable via both pip and conda, and we would like to get to a point to where we're on an individual basis helping people do those publishings. If you don't know how to, or you've never done this before, have someone walk you through it. The documentation hub, I was sharing that as part of my vision last time, and now it exists, so that's great. I just documentation is the main way where we write down how to use these things, so I thought they needed to be unified somehow. The heliophysics software search interface, there's good work being done there, and we're going to hear about that from Isaiah tomorrow. But that helps you discover, software in this field, even beyond Python. But, where the documentation hub is kind of good if you already know what kinds of things you're looking for. The heliophysics software search interface just helps you discover more what's out there. We do need to keep up summer schools, I think, because in-person learning is good. We're still people at the end of the day in a community, and people like the summer school format. Our standards is an obvious one, and we want to help developers meet the standards. I saw making the repo template as a step towards helping people meet those. And then having our partnership with the PyOpenSci for a quality peer review anytime you make anything without needing to wonder where you're going to go find peers to review your stuff. I skipped over this PyHC chat thing in the middle here because I do think AI can bring this all together in some slick ways. But the good news and bad news for this vision is essentially the good news, the good bits here, as I've said, are that the environment has been deployed. That's a win from last time. So it's a documentation hub. HSSI is making good progress. We've identified a vision for the gallery, and I have slides that'll walk through some of these points individually. And then, as I alluded to at the start of this, really the biggest bad news was that PyHC chat was not funded. I even got up in front of a bunch of people at Dash last year and said that we were making this big proposal to hire a full-time developer who their whole job was going to be to develop PyHC chat, and it would be their baby, and it was going to be this beautiful thing. But then Trump got elected and everything went to shit in science funding world, and I can no longer fund PyHC chat at the moment. But the good news for that one is that off-the-shelf tools do pretty much everything it was supposed to do. So I'll have some fun talking about those tools that exist. But to get there first, um, I will say that the PyHC environment, to talk about that, was deployed in December 18th of 2024. And it contains all published PyHC packages. So if the package is in pip or conda, it's in the environment. And there are no dependency conflicts between any of them, which that took some work, but we got there, and it's a good place to be. It's got that welcome page you saw, as well as important unit tests. New from the fall, we have actually added 4 packages to PyHC since the fall meeting, and those are SAMI, which is the shared attribute metadata management interface. It just lets you manage attributes for I have here written down ISTP CDF files using YAML. We've also got the space weather SOC, which is the whole pipeline for analysis tools and space weather processing. SAMI actually is like underneath the umbrella of the space weather SOC. ASI lib was recently added that does similar things to the PyAurora X that we heard about yesterday. That's an open source package providing data access and analysis tools for the world's all sky imager data. And then KaiPy is the most recent one. I just merged that a couple days ago. And they're a Python package for analysis and visualization of simulation results from the scientific software package Kaiju. I actually don't know what Kaiju is, but they had a good package with a bunch of great documentation and everything. So check them out if you want. And then maybe the last thing I was going to say about the environment was just to give people some kind of an idea of what maintaining this has looked like. I mentioned that a bunch of work went into just making it so that there was no dependency conflicts among these packages. And since I've been running this, December to now, there's basically been 10 times that the build has broken, so to say. And 6 of those 10 were because of package changes that introduced a dependency conflict, essentially. So this environment updates nightly. I don't think I said that. So every single night at midnight, it's checking to see if any of the packages have released a new version. And if they did, it tries to pull it in automatically. But, because we're doing that, that means I wake up some mornings and there's an email from my alert saying that a package added a dependency requirement that conflicts with the environment. And then essentially, my process so far has just been to reach out to them through GitHub issues or whatever and just tell them, hey, I know you didn't mean to, but this change you made your package incompatible with the PyHC environment. Here's what you could do to resolve it if you want to be re-included. Would you like to do that? And luckily, everyone's been happy to play nicely when I've submitted those kinds of issues so far. So no one has come back and said, no, I don't want to do that. I'm leaving the environment. And the examples of that, matplotlib and numpy are the biggest offenders, probably not too surprising. But like in May of last year, SolarMach started requiring a version of matplotlib that was too low for the environment. So I opened an issue, and like within a day, they had unpinned that version. When NumPy 2 was released, it broke our build. So I pinned the environment to NumPy less than 2, and we're actually still there to this day. And there's been actually a lot of work by a lot of packages to support both major versions of NumPy, which has been awesome to see. Just a couple times, a package like I think this happened, PyRFU did it once, and then SciQlop did this once pretty recently, where they switched their dependencies to require NumPy greater than or equal to 2, and I would just open an issue and say like, hey, could you please like support both major versions instead of doing that, please? And just through stuff like that, this environment has been chugging along and it works so far. So we've got a community process to keep it working, and I'm happy that it exists. Now I'll try to get through this part really quickly because then I've got cool videos and stuff to show off. But kind of what I'm imagining to do with the gallery is kind of like I said, start with everyone's documentation and maybe even notebooks they have in their repos or whatever. Find all the places where people are already showing off how to use their packages and just use some mild form of AI to lift them from the documentation and put them into a standardized format for the gallery. Also do the kind of nightly auto updating thing that the environment does so that anytime, package documentation changes or a new feature is added, we can make sure to get that added to the gallery. The current version of the gallery actually lets you, what's it called, execute the code right there in the browser. We use like a Sphinx plugin that like starts up a Python environment and then lets you run the examples. I think it's pretty obvious that the PyHC environment should be what backs the browser execution there. So you can still execute everything in the browser and probably even fire up the code in a notebook cell if you want to like start with a gallery example and then expand on it for your own work. Obvious, but I want this to have a modern interface, like actually make it a pretty looking website. And I'm even kind of picturing that this could be right on the PyHC homepage beneath our blog. And this would be a good time to go ahead and just give the whole PyHC website an overhaul to a modern web framework. That would be pretty sweet. And I had this bullet here at the bottom, social media integration for community engagement. This is like the pie in the sky kind of stuff, but I'm imagining just because I want to use an LLM somewhere in the chain of scraping examples from documentation to make sure that they're actually executable and doing simple things like if they hard coded a personal path to some folder on their computer in an example, like the LLM can be smart enough to like change that to a generic path or whatever. Since we'll already have that in there, I want to have one that's just monitoring the changes on maybe a weekly basis or something and making little blog posts at the top to tell people what new features have been added to PyHC lately, or just in general, what changes are happening. And I can even imagine, you know, the simple version where it just stays blog posts on our website, or the advanced version where blog posts become actual social media posts that get blasted out to, all the major platforms. Imagine, and this would all be done in the background without developers having to do anything. So imagine you're like a developer of a package and you add a new feature that you're really proud of. And then suddenly the PyHC gallery picked up on that feature, gave it a feature in the gallery, and made a post on Instagram. And then you went viral. You like open up Instagram, and then you see that you've gone viral for this awesome science thing you added to your package, and you didn't have to do any work. Now I'm going to stop talking about that because none of this exists yet. This is just what I plan on writing into a proposal. Um, but yeah, that's kind of where I'm hoping to go with this. I don't think I actually called out the bullet here that said smart categorization by heliophysics use cases, but that should be a pretty obvious one too, to just, have them curated in some way for what features exist. You can just look through and find what can be done with PyHC packages. Anyway, I'll work on that later. Hopefully we'll be able to get a proposal funded at some point to do that. In the meantime, I wanted to talk about the AI tools that now exist to do everything that PyHC chat was supposed to do.
Sean, before you do that, Nick had a chat question.
Thank you. Let me look at this. I'm wondering if it would help to create a GitHub workflow hosted on the PyHC GitHub to make sure that a project's current requirements are compatible with the PyHC environment. Oh yeah, that's a good thing for me to think about. I will also copy that into the note here underneath Stuart's suggestion. I'll look into doing that. Sweet. Thanks, Nick. So let's see here. I've got, it's 10:38 my time, so just have about a little over 20 minutes to talk about this part. So where to start? I had kind of pitched PyHC chat as, basically an AI chatbot that knows everything about PyHC. And why would you want to do that? Well, you could imagine basically asking any question about PyHC, like what are our standards? What events have we held or are we holding soon? explain the PhET process to us, things like that. You want to know how to use any PyHC package. So rather than reading through documentation, you could just ask, hey, I'm trying to study images of the sun in X way. What packages can help me do that and what features are available? Those kinds of answers would be helpful. Or just like, I know I want to use SpacePy, but I've never used SpacePy. Tell me about SpacePy, that kind of stuff. Getting more into the stretch goal kinds of things, we imagine this being like kind of a coding helper to help you not only just learn about how to use the packages, but actually write code that uses the package for you to do your science. Maybe even in a notebook environment where it could write prose and code to even write, like help you write your whole science paper, even in an executable paper format, because it'll be right there in a notebook. And the biggest, most pie in the sky stretch goal that I can't even believe I'm saying in 2025, the tool for this already exists, is a developer bot floating around GitHub and automatically looking at and trying to address issues that pop up as they are created. So I have a bunch of slides going through each of these points here, and let's just show off how each of these are now doable with off-the-shelf tools. And if you haven't been following AI developments in general over the last like 3 months, hopefully some of this will blow your mind a little bit. And I'll hope to leave time for a discussion on this kind of thing. Um, let's see here. So starting with answering questions, basically it turns out all AI-powered search engines at this point pretty much have the PyHC website and our GitHub things like indexed or findable, however it works, to the point that you can just ask about PyHC to them and they give good answers nowadays. So like this screenshot in Google AI mode, I'm saying explain PyHC's PhET process to me. And it actually finds our FEP1 markdown file as the main source. And it explains that it's the PyHC enhancement proposal process, even breaks down the types of FEPs, like there's standards tracks, informational tracks. If I scrolled below, it was a very good answer. Regular old chat GPT does that too. I can just say, give me the link to the PyHC Fall 2024 meeting materials. And O3 is smart enough to jump on a web search real quick, find our fall meeting page, and then boom, here's the link to the Google Drive. And I did click that, and yes, it was the correct link. Gemini can even summarize YouTube videos nowadays. That model has the largest context and is the only one that works directly with YouTube videos because, Google owns it. So you can just give it a link to a day of the summer school and just say summarize what was taught. And it gives you a nice summary of everything that was covered during day 1 of the 24 summer school. Or this other version of the screenshot, I did it again and it gave me timestamps. I actually didn't know what was the better image to show off with this feature, so I put in both. But it's pretty damn powerful already to be able to like dive back into what happened during the summer school and have a machine reteach you everything that was taught or take a deep dive into certain things that you might have missed. So essentially at this point, you're either, I think, the kind of person who knows you want to use AI in your daily workflow or you don't. And if you don't, well, that's fun. Have fun doing things the old way. But if you want to be using AI to get answers about PyHC, you can do that now. Then to understand GitHub repos, well, I don't know if people knew that this is just built directly into GitHub websites now. So you go to github.com, you look at any repo, there's this cute little icon of the little GitHub Copilot guy wearing goggles. And you click that, and you can ask any question about the package. And at this point, they've got a bunch of secret sauce for reading through and intelligently navigating the files of repos. I don't know how they do it, but you can consider code-based understanding a solved problem at this point because they give you intelligent answers to anything you can ask. I haven't stumped one of these chatbots on a question about a repo in a long time. This example here is just on PySpeedass, and I'm just clicking it and saying, show me how to download MMS FGM data from PySpeedass. It plans a response for a minute, and then it comes back with a code snippet. And if you scroll down, there's even a link to the code file where it got this code from to prove that it's not just making crap up. That's actually real. you can even, so I'm going to pause this for a second. Deep research is a feature that at least OpenAI and Google have implemented now. I think so is DeepSeek. But this is this is one of the first agent use cases that chatbot providers made, where the chatbot not only thinks about its answer before answering you, but it actually goes off and does a bunch of web searches, will work autonomously for minutes at a time, often up to like 10 minutes, and it'll give you deep answers to things, basically just letting the LLM peruse answer space until it feels like it's adequately solved the problem. And in here, OpenAI is demoing that they have linked GitHub repos to deep research. So if you have a really deep philosophical question that a normal, the chatbot on the GitHub might struggle with, you can ask the really hard questions here, click deep research, click GitHub, type the name of your repo, and it goes off. And one of the powerful things about this is it actually works with multiple repos, not just one repo. So if you wanted to do something like compare two PyHC packages and ask, what would it take for these two packages to use a common data model? You could ask that question of deep research, send off the query, and then I'll scroll back for a second. That was very sped up in the video. It thought for 13 minutes just then to write this report. So I have not tried this yet, but it's on my to-do list, very high up toward the top of the to-do list, to actually fire off one of those questions, like how could we improve interoperability between these two PyHC packages, and see if the report actually gives us anything actionable. But just the fact that this technology exists now is super powerful, and this just came out like a few weeks ago, I think. So if you didn't know this is a feature, don't feel bad about yourself because it is very, very new. This is just showing the activity on the sidebar, so you can go back and look at exactly what it did during those 13 minutes, or you can just look at the sources. So if you want to know anything about any PyHC package, there's an AI out there that'll tell you about it. And then if you want to actually have the AI write your code for you, so if you want to just focus on the science that you're doing and you don't want to have to actually write Python code from scratch, well, agentic coding assistants are everywhere now. And these videos have sound coming up for the first time. Maybe not the first one, but I think the second one. So prepare your speakers if you have them turned on. I'll full screen this, and this is going to be showing off both what coding agents look like in IDEs and on github.com right now, where this is in Visual Studio Code, where now there's this right sidebar where you have just a little chat window. And in here, in this example, they're uploading it a PNG of an object relationship diagram. They're pointing it to the server folder in the code base, and they're just saying, implement this diagram. And sorry if this is blurry on your side, but this is the interface that's generally coming to like all IDEs now, where you have this pane on the right that's your chat window, and then you can switch the model, or you can switch it between agent mode, ask mode, or edit mode, and it'll just go off for you.
I see it, I want it, I get it.
And now they're showing off that this has been added not just into IDEs, but now it's fully integrated into GitHub's website. So there in VS Code, they said create a PR for this change, and I'll just let the rest of the video play. Yep. So
the magic.
that's super cool. Just the fact that not only does it exist, but it's been so deeply integrated just into the websites, and it's becoming very seamless to where if you feel like delegating code to an agent to do things for you, you now can. This is the longest video I have in the slides. It's just 2 minutes, but this is showing off the new Codex tool from OpenAI, which I would consider the biggest, shiniest new thing that a software developer could use. This is $200 a month because you have to be in the pro tier to access this tool. So this is really like if you just want to throw money at the wall to get access to the biggest thing. OpenAI's Codex essentially links ChatGPT to your Git repos, but also gives it a cloud environment to actually run your code and execute it and everything so that it can just autonomously build, not just using your laptop as an environment, but using a powerful cloud environment. And this guy from OpenAI will show off here his use case. It's pretty sweet. It's basically he's on the Codex team. He helped build this code, but sometimes he has to be on call for running services. So he's the guy for like if the ChatGPT website goes down or if new features aren't rolling out correctly, he has to like put out that fire instantly. And I'll let him take it over from here for 2 minutes.
For me, of building products is seeing other people use them, get the spark of delight when they start using it in ways that I completely didn't expect. My name is Calvin. I work on the Codex team as an engineer here at OpenAI. It's come together really quickly, but the end result that we're launching to the world is something that frankly is pretty magical in my opinion and has sort of changed the way that I write software as an engineer. Typically when engineers are running services, there's one person or a couple people on the team who act as the on-call. So they're kind of the like first line of defense as like a firefighter for the team. And actually I'm that this week, so it's particularly top of mind for me. At any moment, I might get paged and have to abandon whatever I was working on and context switch to this new thing to figure out what's going on. There are a couple of things that Codex really helps with here. Oftentimes when you're on call, you'll get some sort of alert and you'll kind of look through the error logs and you'll see, oh, hey, there's an error at this one particular part of the code base. And sometimes it's something I'm familiar with, but sometimes it's not. When the minutes and seconds matter in terms of responding to an issue, the first thing I'll do is just fire off that stack trace into Codex to understand where the issue is happening and see if it can fix it. Usually I'll like do that as a first line of defense, and often the results that comes back are pretty good.
Does this make you do what you gotta do?
I'm actually getting paged right now. Let's see. So right now we have like a high number of error or rollouts which are failing. This alert has been a little flaky though. Every time. Oops. Okay. Okay. Another thing that I use Codex for is tuning our alerting. Right now, since we're about to go into launch, we haven't fully tuned this to where it needs to be. Sometimes we get alerting and it's kind of a false positive. Where you used to kind of work as an individual engineer and like you'd have your task and you'd be writing code. Now it allows you to work almost more like you're your own team or like a manager of a team. I can just send it over to Codex. Now I can just consider it done. The magic for me of
Lovely, right? And I just love that during the course of that interview, he was actually organically interrupted with an alert from his thing saying something's going wrong. And you just saw him in just a second. All he does now is just paste the stack trace into it, say, fix it for me, and then close his laptop and go back to the interview. And, these tools have all been used internally by the largest AI development companies for months and months before they release it to the public. And so, OpenAI has specifically been using this Codex tool to put out their fires, etc., for a long time now. So it's not even just a question of like, are they good enough for enterprise use cases at this point? It's like, no, their enterprise is being run this way now. And it's just fascinating to see that. So there you go. Agentic coding assistants are everywhere. And then just the last two things that are very short is that AI in notebooks is a common thing now. So where there was maybe like one plugin to do this when I first pitched the idea of this maybe being a thing, notebook developers got ahead of me and everyone decided at once that yes, this is a good thing. And now pretty much every major notebook provider at least has a plugin that you can install optionally to add an LLM agent inside of the thing. So this is Gemini in Colab I'm showing off here, where I just typed in the prompt, show me how to use Happy's Python client by downloading and displaying the first few rows of a Happy dataset. And then Gemini just populates this code right here. I hit play, and then it correctly downloaded the Happy client and then showed me the first 5 rows of this dataset. And it just looked like here, it pretty much, that's almost verbatim the example from Happy's like README up at the very top. So it just searched the web and just found the most simple example to give. But that's, this is in Jupyter Lab as an extension. This is in Deep Note. This is in CoCalc. This is in like basically all major notebook developers, like I said. So if you want that, you can have that too. And then Claude Code in GitHub Actions is the last thing I'll be showing off. Claude Code being Anthropic's like command line tool for having a coding agent, where you basically just give it access to your machine. It's installed locally, and you just like let it run through your repo, and it'll like run shell commands or change the code, test things for you, etc. by itself. Claude, I'm calling out here partially because they have the best coding model in the world at the moment. It's kind of been a race, between OpenAI, Google, and Anthropic. First, OpenAI released o3, which blew everyone's minds and set the standard for coding. And then very shortly afterwards, Google announced Gemini 2.5, which was at the top for a little bit. And then just while I was on vacation, like a week and a half ago, Claude 4 Opus came out. And that thing is an absolute beast that is crushing the benchmarks. But they've taken this terminal agent development tool and they've added it as a thing you can plug into GitHub Actions. So now in this demo, this is not too dissimilar from the Copilot demo where they're showing it do something automatically in a PR. Look at this, and Claude comes back, addressing the feedback, running the tests, verifying. And of course, they just merged the code right away at the end of the video without looking at it. But because that can be arbitrarily added into GitHub Actions now, you literally could use that exact tool today to set up like a Git issue monitor on all the PyHC repos. And anytime an issue was created, you could have Claude go in there and just automatically give like an AI generated fix to the issue. And in the current state of things, I'm not expecting that that would be the most useful feature in the world. It's just kind of amazing to say that that exists. And if we wanted that to be a feature of like a PyHC chat kind of system, there's what we could use for it. So yeah, that's pretty much the whole thing. I had this vision of PyHC chat to be a one-stop shop to learn anything about PyHC, understand all the packages, standards, steps, meeting summaries, execute code to solve problems, and help you do research, write your code, and write your papers too. And while that does not actually exist yet, all the tools could be glued together to make such a thing. And what an exciting time to be alive. I think I'll just kind of leave it there.
Awesome work, Sean. Anyone have a question or a comment?
Just a little back and forth with Sean and I in the chat for those that are curious. We're both heavy code assistant users, but I think we have half empty, half full approaches.
Yeah. And then we're just having a little discussion where, of course, code quality can be questionable from these kinds of things. So I was commenting that using the current paid and frontier best models is always the best idea. And a lot of them now have like, tool calling built in, like web search or specifically Git repo searches. So if you let tools verify the code that they say through tools like that, they give you, they hallucinate less and are more useful. Yeah, hopefully at least someone there saw a couple new tricks with tools that you didn't know was possible, and I hope some of that was at least looking impressive. And
So I used ChatGPT to come up with some of my demo for Cloud Catalog today because I had stuff that was very programmery, but I'm like, oh, fetch OmniWeb using these 3 different Python clients so I can show the compare contrast. And it was so much quicker than looking up the APIs for each. So it is definitely PyHC aware.
That's amazing. All right, any final comments or questions? All right, cool. Well, thanks everyone who presented today. Tomorrow is going to be the short day, only an hour long of an official meeting, 9 to 10 a.m. Mountain Time. And it'll focus on kind of some scene setting presentations for the HSSI, as well as a couple working sessions, basically just gathering feedback on some of the things on the metadata side of things we've been working on. So come prepared for that, and I'll see you all tomorrow.
Thank you.